Hey everyone, this is the Mendelian genetics notes on monohybrid crosses. With monohybrid crosses, the word mono means one, so in this case you are testing one trait and one trait alone. So please make sure you are using the same letter for both your dominant and your recessive. Use the same letter for your dominant and your recessive trait. That is very, very important. And what we'll do is we'll use as for our dominants, we're going to use the capital letter or the capital version of the letter. And then for your recessive, we're going to use the lowercase. So with your monohybrid crosses, these are your Punnett squares. Again, we're testing for one trait. Your monohybrid crosses are going to be used to show the law of segregation. And when we do these monohybrid crosses, you're going to use them to calculate some probabilities. What we're going to then do in AP, one of the biggest differences between AP and in ninth grade, is now we can use those probabilities for some calculations. And what we're going to do is we're going to use the probabilities that you get in the monohybrid cross as our expected values, or to solve for expected values in chi-squares. So if you calculate that 75% of the offspring should be this characteristic, and there's 1,000 offspring, then what you would do is multiply 0.75, this probability, based on your monohybrid cross, and then multiply that by the size of your population, and that's going to give you your expected value for a chi-square. The observed values in your chi-squares are going to be the actual babies or the actual offspring. Sorry about that. The actual offsprings. The observed values are the actual number of offspring. That's what I'm trying to say. Of offspring produced. And then you can compare this, use this to calculate a chi-square to find out if the trait followed Mendelian genetics. If it follows Mendelian genetics, then you can use these probabilities to find out what the expected value is going to be. 75% this, 25% that. And so those expected values you can use to compare to the observed values to see if this trait is following traditional Mendelian genetics. Thanks for watching.